Good afternoon, everyone. So when Nana and Georgia asked me to have a short presentation here, they said I have to speak about the sustainability challenge in aviation. So I thought about that, and actually the biggest challenge is that we do not know what sustainability is. Okay? If we ask around here, we will have very different opinions. And I'm a mechanical engineer. I have to know what sustainability is in order to design or assess, and also maybe I have to use as an assessment or even to design something based on the sustainability. Do we agree on that, more or less? If we speak about noise, we know perfectly what noise is. How do you measure noise? Decibel, right? How do we measure sustainability? We do not know. So this is the biggest challenge in order to address sustainable aviation. We have also to think about what sustainability is. Any thoughts on that? We'll have different thoughts. Let's take an example to see if we can manage out. Take, for example, here you have jet fuel airplanes as today, and we change them with sustainable airplanes. Can be hydrogen, can be synthetic. Even if we manage, is it something that's sustainable? Can we say only by changing the fuel, is that sustainable? Or if we take this picture, the same picture you can be seen in all the big European countries. We have now gasoline cars. If we replace them with electric cars, can we live in something like that? Is this sustainable for us? So maybe a point that I want to make here is that sustainability is not only technology related. Okay, so maybe it's not our part as engineers to solve sustainability. Maybe we can somehow contribute, but maybe it's something more than that. So what can it be? A lot of us will say it depends, maybe on the application. You've seen these photos a lot of times, I'm sure. You see here, this is from Airbus, the fleet that they want to make. You see here the envisaged aeroplane is a little bit different from the ones that we fly today. And why is that? Because if we want to put hydrogen inside, we cannot put there where kerosene is. Do you know where we put kerosene? Maybe you know where we put it on the wings. Thank you, on the wings. So we fly with full wings of fuel. Okay, it's safe, but we cannot do it with hydrogen. We have to put it somewhere. So when we change technology in order to make something more sustainable, then we have to change the design, the whole design, a radical design. Even if we say here we make the tail bigger, it's a radical design for us as aerospace engineers, let's say, or something like that from Boeing. So, okay, and why is that more sustainable than the ones that we fly now? The current state of the art, based on the UN, and you all know the SDGs, I'm sure, the main idea is that what we can do is to meet the needs of the present people without compromising the ability to future generations. So don't destroy the planet and so on. And you have defined very good SDGs. But all these SDGs are good, but for me as a designer, I cannot per se work on an airplane that has a better gender equality inside. Passengers are passengers. Maybe there are some parts, but we can change based on, men are normally bigger than women and so on, which is, but still it's not something that can be somehow used for my design. So this is very general, and we try somehow, and this is the challenge, I believe, to make it more specific. Okay, how we understand today sustainability in aviation, we mainly understand it as environmental sustainability. This is the eco-design standard, a lot of projects on that, perfect job, wonderful job. What we try to do is reduce the climate impact, of course, that's correct. So eco-design is understood as the integration of environmental aspects into product design and development with the aim of reducing environmental impact. But someone could say this is only climate friendly, it's not sustainable, because what happens if it's more expensive? What happens if you use a fuel that can be toxic? And so on and so on. So what we believe and try to somehow make this transition is say, okay, it's not only about eco-design, it's not about climate, but it's a trade-off of 5 main pillars. Of course, it's the environment, but of course the performance. It should fly from A to B. It should be the cost. No one will buy, even if we increase the fuel consumption or the prices and everything. It will not work because no one will buy it, or the companies will not invest in this solution. It should be circular, meaning that the materials that we put inside should be used again somehow, even in the better is the same sector or in other sectors, so downcycling. And what we all almost forget, but I'm very glad here because there are a lot of presentations that do not forget, is the societal part. A lot of good technologies fail because the society does not accept them. Especially in Greece, we see with the wind energy and so on, because no one takes this part. And of course, this is a trade-off. So also, Anna, you showed in your presentation that you write something about the balance, about, I think, performance, society, and something. So this is the same idea. We try more to formalize it for ourselves as design engineers. And we try somehow to use this. How do we, what is the idea? Is to propose a C index, a metric, that can integrate these 5 pillars: performance, cost, environmental, circularity, and social impact, in one single index that can be used as a decision support tool at the end, that can help us to assess, based if the performance changes a little bit, the cost changes a little bit, in the general, if a solution and technology can be more or less sustainable. Here I would like to pinpoint also the case, which is weight factors, which can be very different and can add and can be, for example, what happens if we think all about this, that they are equal, then everyone takes 20% and so on. And here the problem is, or the beauty behind that is that when we check this proposed index, which has a lot of, it's a very low TRL, there will be a question that says, okay, and how do you manage the weights? What is more important? Is performance more important? Circularity? And of course, a good engineer will say, it depends. This is the best answer we give always. And it depends from the understanding that sustainability is not a technological part. It's not something that we can solve as engineers, but it's a socio-political thing, an index or a social political thing that gives us different priorities. Before, let's say, last year, European Union was saying most important is environmental, climate friendly, and so on. Now we have changed a little bit. We put also competitiveness in the beginning. So costs now take more value, bigger weight. In the USA, in the Americas, they have different values. In the Asia, they understand sustainability very different as we do. Don't say it's better or not. So using this, we can somehow try to assess and measure that. We start that very basically. I will show you only one small idea how we do that. I'll not go into detail. This is a typical Hatch-Stephen panel. This is a very basic component in the fuselage of the aircrafts. Maybe you have seen it. When you see it, it's next to you, between around you, the fuselage. And then we say, okay, we can have a reference, and how can make this more sustainable? What we can do as engineers, we can change a little bit the geometry, and we can change the materials. The materials play a very important role. We can use typical aluminum or carbon fiber, so plastics for the ones that do not deep on the materials. or some other types, and play with that. One can be aluminum, one can be plastic, and so on. So we can then take information about the type of material, if it holds, how much does it cost, and so on, and then make a first assessment which design configuration is the best. Okay, based on different pillars, and especially on the general part, which is the sustainability index. And now in this case, we see that, for example, aluminum is the best, or not the best, the most sustainable under these considerations. Not only that, we can also assess some geometric figures. You see them with the sign plus, minus. I don't know if you like statistics. I have time, I know, 3 minutes is more than enough. I believe no one likes statistics, but they're very important because it shows that, okay, if I change something here, actually this will not change. Having said that, for this maybe it's aluminum, and I'm not objective. I don't have an objective opinion on that. I've worked 15 years on composites. So to show here the more sustainable solution is a metal part. It's a bit contradictory to my own career, but maybe it's like that. And on this we try somehow then to scale up and see not only on the component level, but also on a subsystem or a system level. And we do that in 2 projects currently. One is the Exaelia project, where we work also with DLR, with Pratsval and his group. There we try to understand how we can assess different designs of aircrafts based on sustainability, but before on that we have to understand the needs and the requirements, and we do that in work package 2, and then together with Pratsval we try to assess the impact of a specific long-range aircraft configuration, how sustainable or more or less sustainable that could be. The project just started. We'll have the first results in October, November. And the second, and this is something that we do for the assessment. We could do that also for the design, but we're not so high TRL yet. And another project that we like to pinpoint is the Impact Monitor. Impact Monitor 2 is a continuation of Impact Monitor. Deller and Pratsval coordinates that. We are partners inside, and here we try to see how different technology and policies regarding all of this environmental, economic, and societal impact affect our society. For me, all these pillars is sustainability. I could say sustainability assessment, but we didn't write the title like that because I was not. I was not the coordinator, and that, of course, this is not the project's objectives. I'm just kidding here. But still, this is also another project where we can also help and put some of these ideas inside. So to sum it up, we have not defined sustainability. We somehow, everyone has another idea. We try to put it together with the global sustainability goals. That's good. Maybe in the next years we can somehow try to understand, have a common understanding, at least in Europe. This can help us then in 2 ways. On one side, for me, to use it as a design criterion, so we can design something that I can say it's more sustainable, but also then to assess different technologies or different systems using always multi-level approaches, because as you saw, it's a very multidisciplinary part. So that will be all from my side. Thank you very much. This is our campus. Yeah, this is showing off a little bit the campus in Patras with a nice bridge and so on. We are situated here. You are welcome all to visit us, make a sabbatical maybe. We're very close to the beach, and it's a wonderful place to live and work.
Where's the brochure? Okay.
Yes, the disclaimer at the end.